Wow, just listen to that crackle, feel the heat radiating outwards. Look at that, fire, a mesmerizing dance of light and energy. It's a fundamental force of nature, captivating and powerful. We see it everywhere. On birthday cakes, a symbol of celebration and joy, marking another year of life. In cozy campfires where stories are shared and friendships are forged under a blanket of stars, or as a candle's gentle glow, a beacon of hope and tranquility in the darkness. Fire is bright, a vibrant display of color and intensity, warm and full of energy. It provides comfort and sustenance, a source of life in many ways. It can be tiny like a match, a small spark with the potential for great things, or huge like a forest fire. A destructive force reminding us of its immense power and the need for respect. But what is fire? What is this phenomenon that has captivated humanity for millennia? Is it alive? Does it breathe? It sure seems to move and grow, consuming fuel and spreading its reach, but it's not a living thing. It doesn't have cells or a consciousness. Fire is something else, something more complex than it appears. An incredible force, a fundamental process that has shaped our world. That's been vital to humans for thousands of years. It's woven into the very fabric of our history. Early humans used fire for warmth, a refuge from the cold and a source of comfort, safety, warding off predators and illuminating the darkness, and cooking, transforming raw ingredients into nourishing meals, which changed how we lived, allowing us to digest more nutrients and develop larger brains and where we could survive. It expanded our horizons and allowed us to adapt to new environments. Imagine life without fire, a world drastically different from the one we know. No light at night, shrouded in darkness and vulnerable to the unknown. No warmth in winter, constantly battling the elements and struggling to survive, and no cooked food. A limited diet, hindering our development and overall health. The discovery of fire was a turning point for humanity, a pivotal moment that changed everything, helping us thrive, allowing us to flourish and build complex societies and spread across the globe. It empowered us to conquer new territories and adapt to diverse climates. Fire isn't just a tool, it's more than just a means to an end. It's a revolution that shaped our world. It's the foundation upon which our civilization is built. So what exactly is happening in those dancing flames? What's the science behind this captivating phenomenon? Believe it or not, it's all about chemistry, the interactions of molecules and the release of energy, the science of how things change. It's a process of transformation, breaking down old structures and creating new ones. Fire is a real-life example of chemistry in action, a visible demonstration of scientific principles right before our eyes, a chance to witness the power and beauty of chemical reactions. Get ready, science explorers. Prepare to delve into the fascinating world of fire. We're about to uncover the secrets of burning, unraveling the mysteries behind this ancient and powerful force. Put on your thinking caps. It's time to engage your curiosity and explore the science of fire. This is going to be illuminating. We're about to shed light on the science behind the flames. When you see fire, you immediately notice the flickering flames, dancing and weaving in the air. It's a mesmerizing sight, isn't it? You feel the warmth radiating outwards, a comforting embrace on a cold day, and maybe you catch a whiff of smoke, a telltale sign of the transformation taking place. But fire isn't just sitting there, passively providing light and heat. Fire is a dynamic process, constantly changing and evolving. It's a rapid transformation of material from one form into something entirely new, a fundamental shift in its very essence. And in the process, it's releasing energy in the form of heat and light, illuminating the world around it. This process, this energetic conversion, is called combustion, a fancy scientific word for the everyday act of burning. Combustion, at its heart, is a chemical reaction, a fundamental interaction between substances. It's not magic, no matter how magical it may appear to our eyes. It's a very special kind of reaction, one that produces both heat and light at an incredibly rapid pace. While most chemical reactions occur slowly, almost imperceptibly, or are subtle in their effects, combustion is dramatic, visually stunning, and exothermic. It releases a significant amount of energy in a very noticeable way. So let's break it down further. What exactly a chemical reaction? It's fundamentally when substances, which we call reactants, come together and interact with one another. This interaction leads to a change, transforming them into entirely new substances, known as products. Think of the process of baking a cake as an example. You begin with a set of individual ingredients, then you mix them together and bake them in the oven, and ultimately, you end up with something completely new and delicious. In the case of fire, the fuel source, whether it's wood, paper, or another flammable material, undergoes a reaction with the oxygen present in the surrounding air. This reaction proceeds at an incredibly rapid pace, transforming the original fuel and oxygen into entirely new substances, such as smoke, various gases, and ash. This rapid and intense chemical change releases a significant amount of energy into the surrounding environment. And that energy manifests as the heat and light that we can feel and see. The flame that you see before you, that's the visible manifestation, the tangible evidence of this energetic chemical transformation taking place. Fire is essentially a hot, glowing, and ever-changing chemical dance. It's chemistry in action, a process that you can not only see and feel, but also sometimes even hear in the crackling of the flames. And that's precisely what makes fire such a captivating and endlessly fascinating phenomenon. To make fire, you need a special recipe, a combination of elements that must come together in just the right way. It's not as simple as just striking a match. There's a science to it. Fire requires 3 essential ingredients. These aren't your typical cooking ingredients, but rather fundamental components that enable combustion. If even one is missing, there's no fire. The absence of any single element will prevent the chemical reaction from occurring. No sparks, no flames, no warmth, just coldness and darkness where a fire should be. These 3 things make up the fire triangle. It's a simple model that explains the necessary components for fire. Picture a triangle, a shape with 3 distinct sides. Each side represents one crucial ingredient. Each element plays a vital role in sustaining the fire. The first side is heat, the energy needed to start the combustion process, a source to get things started. This could be a spark, a flame, or any form of ignition. The second is fuel, the material that burns. This can be anything from wood and paper to gasoline and propane. The third is oxygen, a gas in the air we breathe. It acts as an oxidizer, allowing the fuel to combust. All 3, heat, fuel, and oxygen, must be present for fire to ignite and keep burning. Without all 3, the fire simply cannot exist. Think of the fire triangle like a 3-legged stool, a stable structure that relies on each leg for support. Remove one leg and it collapses. The stability is immediately compromised. Fire works the same way. It needs all 3 components to maintain its existence. Take away any side and the fire goes out. It's a fundamental principle of fire control. This simple idea is key to both starting and stopping fires. Understanding this concept is crucial for fire safety. Understanding the fire triangle helps us control fire and prevent unwanted ones. It's the foundation of many fire safety practices. It's a powerful concept in fire safety and science, used by firefighters, scientists, and safety professionals alike. Remember, heat, fuel, and oxygen. Fire needs them all. They are the essential building blocks of combustion. Break the triangle, and you break the fire. By removing any one of these elements, you can extinguish the flames. Let's zoom in on fuel, the fire's food. Fuel is anything that can burn, providing energy for the fire. Without fuel, there's nothing for heat and oxygen to work on, no fire. Common fuels include wood paper, dry grass, gasoline, natural gas, and even candle wax. Different fuels burn in different ways. Twigs catch quickly and burn fast. Logs burn slowly and give off more heat. The type, size, and dryness of fuel affect how easily it burns and how hot it gets. Fuels store chemical energy inside their molecules like tiny batteries. This energy often comes from the sun captured by plants. When fuel gets hot enough with oxygen present, burning starts. The chemical reaction breaks fuel molecules, releasing stored energy as heat and light. Fire is a rapid release of energy from its food, the fuel. That's what actually burns. Now let's talk about heat, the spark that starts it all. You can have fuel and oxygen, but without heat, there's no fire. Heat is the ignition source, providing the energy to get the reaction going. It can come from friction, like striking a match, an electrical spark, a hot surface, lightning, or even focused sunlight. The amount of heat needed depends on the fuel. Paper ignites easily, but a damp log needs much more. Every fuel has an ignition temperature, the minimum heat needed to start burning. Once the fuel reaches that temperature, the fire party begins. Heat is the trigger for the whole fiery process. The third side of our fire triangle is oxygen, an invisible gas all around us. Oxygen makes up about 21% of the air we breathe and is essential for fire. Without oxygen, Fire can't exist no matter how much fuel or heat you have. Fire is an oxidation reaction. Oxygen combines with fuel to release energy. Try this: light a candle, then cover it with a glass jar. The flame goes out when the oxygen runs out. Oxygen is an active participant in burning, not just a bystander. During combustion, oxygen molecules combine with fuel molecules, breaking them apart and forming new substances. This releases energy as heat and light. The new molecules are often carbon dioxide and water vapor. Oxygen is fire's invisible friend, making the whole process possible. No oxygen, no fire, simple as that. That's why controlling oxygen is key to fire safety. So what's really happening when something burns? Let's zoom into the world of molecules. Fuel is made of molecules with energy stored in their bonds. Heat excites these molecules, breaking some bonds and turning solid or liquid fuel into gas. These vapors are what actually burn. Oxygen rushes in, combining with the vaporized fuel molecules. The atoms rearrange, forming new molecules and releasing extra energy as heat and light, the flame you see. The new products are gases like carbon dioxide and water vapor, plus smoke. Burning is a rapid transformation, releasing energy and creating new substances. Knowing the fire triangle isn't just cool, it's practical. To stop a fire, remove one side of the triangle: heat, fuel, or oxygen. Firefighters often use water to absorb heat and cool the fuel below its ignition temperature. Removing fuel, like creating fire breaks in forests, starves the fire. Cutting off oxygen, like smothering a fire with a blanket or using a CO2 extinguisher, suffocates the flames. Each method breaks the triangle and puts out the fire. These principles are used every day to keep us safe. Whether at home or outdoors, understanding how to break the triangle is key to fire safety. Remove heat, fuel, or oxygen, and the fire is gone. Simple science, powerful results. That's the magic of the fire triangle. Now you know the science behind fire, combustion, and the fire triangle. Understanding fire isn't just cool, it's essential for safety and smart living. Fire has helped humans cook, stay warm, and build civilizations. But it's also dangerous if not respected. Most fire safety rules come from understanding the fire triangle. Keep fuel away from heat, ensure good ventilation, and use smoke detectors. This knowledge saves lives and protects homes. Next time you see a flame, remember the science at work: heat, fuel, and oxygen. Respect fire's power, use it wisely, and stay safe. Science is everywhere, even in a simple spark. Stay curious and keep exploring. The world is full of wonders.